Start. Hello everyone, welcome back to the performance engineering session with Anson. In this today's session, basically we will be monitoring performance characteristics of the microservices in GCP. Okay, so let us get into GCP console. Okay, so this is the GCP console. Basically, we'll start with the cluster. And by the way, here we're not spending any time to understand how exactly this cluster is created, how to deploy microservice applications into the Kubernetes, or how to allocate the resources and all those stuff. Okay, basically here we are trying to understand how exactly microservices works in the Kubernetes in GCP, and how do we monitor various performance parameters like hardware parameters like CPU, memory, network, IO at the pod level. And another parameter is also on the pod auto scaling. Suppose when we have, let us say, for a certain workload, for a certain user load, we may have two pods, okay? And if user load is increased, you might have to create more pod in order to serve the additional user requests and so on and so forth. Okay, that's what auto scaling, as we all know. Yeah, so let us start with the clusters. This is the name of the cluster is my cluster. Okay, if you open the my cluster, then we can see these are the specifications of the cluster. Basically here this is the nodes section. Okay, here we have two pools. One is the default pool, another one is my pool. Basically this default pool is a kind of a default pool that will be created when you create a cluster. And we can observe here number of nodes is 3, and this pool cannot be expanded. So we always will have 3 nodes available in the default pool, because this auto scaling is switched off for this particular pool. Another one is my pool. In my pool, we have one node at this point of time, so it can be expandable. So basically here auto scaling is enabled, and it will vary from 1 to 3 nodes. So as we know, auto scaling happens when there is a need for more resources in order to serve the user load. Yeah, so as we see here, there are 4 nodes are there. Specifications of 4 nodes will be available over here. So this is name of the node. When I say node, it is nothing but a VM instance. Okay. Yeah, so CPU requested, CPU allocatable, memory requested, memory allocated. So here we have various parameters. Yeah, if you see here, this is there is a little different in the convention. How do we allocate the CPU? It says M CPU. Here M stands for milli CPU. So what it means is 1,000 milli CPU is equal to 1 CPU. Okay, if you need 2 CPUs, then we have to mention it is 2000 CPU. Okay, that's how the convention we follow here. Okay, so by the way, there are, as we see, there are 4 nodes. And in each node, we have around this node 0.5 CPU, and these 3 nodes, it is close to 1 CPU we have. Okay, so that is the at high level of exactly our uh, nodes configuration is. Okay, so this is about the pool and the details about the nodes. Okay, now let us get into the workloads. So what is workload? Workload is a deployable unit of computing that can be created and managed in the cluster, or also it can be called as a application that runs on Kubernetes. You can also call it as a um, workload. Also the I mean we are and also we deployed these microservices into this particular cluster. These microservices utilizes or make use of resources available in the my cluster. So in my cluster, as we saw, there are 4 nodes available, and each node is having one CPU each almost, except the last one where we saw around 0.5 CPU in for that particular node. Okay, so that's how the configuration is all about. So by the way, these are all the workloads. Okay, and these workloads runs on a certain pod. Okay, so pod is it is what do you call pod? Pod can contain multiple containers. Okay, so and it is a kind of a virtual again. It will have its own IP address, and it will make use of the resources, on which this particular pod is deployed. Okay, so that's how this pod works. Okay, so if you observe, there are around 10 plus microservices are there, or 10 plus workloads are there. For each workload, one pod is allocated. It means this add service runs on one pod, this runs on another pod, so on and so forth. Except for the pod, except for the workload front end. Okay, this front end, if you observe here, this runs on the two pods. Okay, so if we get into the details of the workload, okay, so we can view the details of any other workload for that matter. Now we can see the front end workload a little bit in detail. Okay, so this is the front end workload. Here, name of the cluster on which this workload is configured is my cluster, and namespace is default. We don't have any labels for this, and this is the replicas. Okay, so we have two replicas available at this point of time. So basically, when we have more replicas, so one of the advantages is availability. Okay, so if due to some issues, if one of the pod crashes, then our topic can be diverted to the another pod which is running in the system. So while Kubernetes brings up the pod which got crashed. Okay, so that's how it is. Okay, if you see, there are two pods. It runs on two pods. This is pod one, another one is pod two. Both are in the running status. Okay, so basically this front end is the front end workload. Front end deployment runs on two pods. Okay, and both are running at this point of time. Okay, so here is the front end deployment, and in order to access all the workloads or deployments, what we saw in the workloads can be accessed through the load balancer. It is a front end external load balancer. This is the IP address of it. Okay, suppose if we click on this particular IP address, so this is the application we get. Okay, basically this is the application which we are testing at this point of time. Okay. Yeah, so this is pretty much about the one of the workload. Okay, so second one is the details. I don't think here we have anything to understand at this point of time. Okay, so except for the auto scaling. Okay, so here it is auto horizontal pod auto scaler. So basically, um, see, as and when user load is increases, right? So if at all we can create additional pods. Okay, so it will be kind of a cost effective because if you have more parts unnecessarily up and running, so we have to reserve the CPU and memory for that particular um, a deployment. Okay, so we can have minimum number of workloads or minimum number of deployment replicas. Sorry, it is replicas. Okay, as and when we get more and more load, so with the help of the auto scaling, we can create more replicas so that it can generate so that it can manage the additional load that comes to the system. Okay, so that's how it is. So if you see here, for this name of the workload or deployment is the front end. Okay, name status is okay, and minimum replica is 2 and the maximum replicas is 5%. Okay, so it means auto scaling happens between 2 and 5. Okay, so what is minimum replicas? Minimum replica is, it is the minimum number of replicas that will be available irrespective of the load on the system. And what is maximum replicas? Maximum replica is the maximum replicas that will be created, so as and when load on the system increases. Okay, so that is the that's how auto scaling works. And in this case, another one is the CPU utilization. So here for auto scaling, there should be a criteria, right? Okay, so when should it adds resources, or when should it removes the resources from the system, right? Okay, so for that, what is the criteria here is CPU utilization. Okay, so whenever CPU utilization goes above 80%, so then it will trigger auto scaling and it will create additional pods. Okay, yeah. So another thing is, yeah, here we don't have other tabs are not required at this point of time. Either events, logs. Okay, so these are not required at this point of time. One important thing what we need to understand here is, especially on the resource allocation. For example, if you see here, when you over on the chart, we can observe three parameters: limit, requested, and used. You can see here, right? So here limit is 0.4, requested is 0.2, and used is 0.016. Okay. So what exactly is this is, when I say limit, this is the maximum limit of the CPU that can be allocated to a given pod. When I say 0.4 for this front end, so Kubernetes can allocate 0.4 CPU. Okay. So though we get more load, okay, so allocation will not go beyond that. After auto scaling happens, this may go up, that is a different story, but at this point of time, so it can allocate only zero point 0.4 CPU. Again, when you have two nodes, two pods, sorry, when you have two pods, so for each pod it is 200 CPU has been allocated. And yeah, so that is another point to understand. So basically, in this kind of a deployment, so we have to allocate CPU and memory to a particular pod. Okay, so now for this front end, if you go to the YAML file. Okay, one thing I missed, sorry. So if you go to the YAML file, in the YAML file, we have to specify how much is the memory and how much is the CPU that should be allocated to a given deployment. Okay, so where do we get that? Yeah, so this is the place where we can see resource. Okay, so when I say resource, so there are two things: limits and requests. Okay, so limit is something, it is the maximum resources that can be allocated to a deployment is called as limit, and requests is something which is the minimum guarantee of the resources that particular deployment or workload will get it. Okay, so these are the two important parameters to understand when it comes to monitoring of microservices. Okay, and same thing applicable for the memory as well. Okay, so there is a limit on the memory, there is a request on the memory. These are the two things to understand. Okay, so for this pod, how much is the CPU allocated? It is 0.2 CPU, that is the max limit, and under them, that is zero point 0.1 CPU. So that is the minimum CPU that front end deployment gets uh, always. Okay, so that is the thing. But if you see here, okay, it is 0.2 and the zero point 0.1 visa, but in this graph it is showing zero point 0.4. This is because for this front end now there are two pods are there. Okay, for each pod it is zero point 0.2 limit and zero point 0.1 for the zero point 0.1 is requested. Since we have two pods, zero point 0.2 plus zero point 0.2, it is zero point 0.4, that is the limit, and requested is zero point 0.1 for each pod, so it is zero point 0.1 plus zero point 0.1, it is 0.2. Okay, this is the kind of resource allocation happens at the pod level, sorry, at the deployment level. um, yeah, at the deployment level, same concept or same strategy is being applicable for memory and as well as disk as well. Okay, so this is something which we need to understand. Okay, so and this is how we can monitor CPU, memory, and disk utilization of this particular microservice. Okay, so as I said in the beginning, okay, basically this front end, all the workloads for that matter, will get the resources from the nodes that are created in the cluster. At this point of time, we have 4 clusters. Okay, let us assume we have generated so much of load on all the microservices. Then if at all and also auto scaling is also enabled, let us assume like that. So in that case, what happens? So as and when new pods are created for workloads that we have created, okay, so then it will direct GCP to add more nodes. Sorry, not to add, basically to auto scale the nodes. Okay, if you remember, so we have two pools. One of the pool, it is expandable. It is auto scaling is enabled for that, so it can vary from 1 to 3. Okay, so as and when we create more and more microservices, sorry, when we generate more and more load on these deployments, okay, definitely it needs hardware resources, so that um, this workloads will in turn request EKS to request a GCP to create more nodes. Okay, so that it will get sufficient resources to handle the user load. Okay, so that is the concept. Okay, Now, enough of theory. I think what we can do now. So, as we all know, this is the Geometer. Basically, we use Geometer to generate the load on the application. Okay. Basically, here we are trying to hit the this particular page. Sorry, this particular page. Okay. This in turn generates load on the microservice front end or deployment front end. Okay. So there are two aspects now. First aspect is, let us try to understand how exactly CPU memory parameters increases as load on these front end microservices increases. That is one point to understand. So another point is, at this point of time, for this particular microservice, there are two parts are there. Okay, let us see if at all we generate a more load. Okay, such that these two if at all we generate more load on the front end microservice. Okay, such that CPU utilization CPU utilization on of the part where this front end service runs goes above 80%. So then there are chances that EKS will create um, another pod. Okay, another pod, I mean another replica. So then we will have three pods here, so that we can monitor if at all load is moved. So otherwise, at least we can see how CPU memory network increases over the period of time. Okay, yeah. So let us start the load. So basically here we are generating in a incremental fashion. So basically it will start with how much user load, 900 user load. So after that, again, we are adding up 200 user, again 200 user, again 200 user. That's how it goes. The reason behind why we are generating incremental load here, we are trying to see, okay, we are trying to map how increase in the user load will have impact on the front end microservice, this particular microservice. Okay, so that is the objective why we are generating incremental load of the application. So I'll pause for a minute so that system will have a sufficient load. Okay, so once we back, we'll try to see um, whether whatever load we are generating is sufficient to generate CPU utilization of uh, 80 plus percent. Okay, so that it can create another pod. Okay, and that we'll see. Okay, at least at this point of time, so we can see there is a little increase in the CPU utilization. Okay, so that's what it is. Okay, I'll be back in a minute so that we can see what is the impact of load generation on this particular setup. Yeah, so actually, if you see here, we started load of around 1,100 users, but still utilizations on this particular server is not going beyond 50%. Okay, so that is the kind of behavior we can see now. Okay, uh, okay, so we generated additional load of again 1,100. Maybe we can wait for 1 or 2 minutes again to see if it has to auto scale. So otherwise we can do some other experiments that we can do. Okay. It is yeah. So what we can do now, let us conduct another experiment. Okay. So not scaling one. So what we can do now. So what happens if one of the pod crashes? Okay. There are cases where one of the pod may crash during the production, right? Okay. So because of any reason, because of any reason, so there are chances that one of the pod may crash. Okay. So now we basically so we can we're not able, at this point of time, we are not creating any load which will create, which will crashes the pod. So rather what we will do, we'll delete the node. Okay, let us see how exactly system behaves. Okay, so what I will do, I going to delete this. Okay, so I am deleting one of the pod. Okay, there are two pods allocated for front end. So in that I am deleting one node. Now let us see how exactly our Kubernetes behaves. Okay, so one pod is deleted. Okay, so there were two pods. Okay, so here I can say there is a error message saying that pods have warning. So can we see, is there any error in the Geometer? Yes, there are some errors in the Geometer. Okay, so it means it is not able to, I mean, basically, so whenever one of the pod crashes, right? Okay, so whatever transactions that are assigned to that particular pod, so has to be taken care by the application. Basically, we have to retry so that there will not be any errors in the application. So that is the kind of logic. So we have to implement. Okay, but that is not yet implemented in this particular case. But however, if you observe here auto scaling happened. Okay, to some extent. So what is that? If you see here, I deleted one of the node. Okay, so momentarily we could see some errors here. So maybe I think now logging is not enabled for this particular application execution. So otherwise, we could have seen what exactly is the error. So otherwise, when I deleted the node, so what Kubernetes does, Kubernetes immediately created another node. If you say, then now there are two nodes are there. Okay, so but momentarily there may be failures if application is not resilient. Um, Application is not resilient, then momentarily there may be errors. But however, Kubernetes, that has to be handled by the application, by the way. But immediately Kubernetes will created the additional pod in order to manage the load. Okay, so it is the takeaway we can say here. Okay, so and also we can see auto scaling is also happened, okay, kind of, and I can say, but earlier it was only one node. So since we have mentioned that minimum number of nodes in the system should be always two. Okay, so when I deleted one of the node, it's created same node in front of, so in place of node one. Okay, yeah, thank you very much for watching this video. So in general, in general, so what exactly we discussed in this session is, so we have one cluster, and that cluster is my cluster, and we have one microservice, I mean, application developed using microservice is deployed in this cluster. So, I mean, Kubernetes is the orchestration tool. Basically, we understood how exactly memory, CPU, and disk allocation happened at the pod level. So that's one thing we understood. And also, when we generated the load on one of the deployment, when I generated the load, we observed how CPU, memory, and disk utilizations. Uh, we monitor the CPU, memory, and network and disk utilizations. So, and also we were waiting for auto scale to happen, but though we generated the 1,000+ user load, looks like two nodes might be sufficient in order to handle such load. So then what we have done, so there were two parts for there. So we deleted one of the node. Okay, so when I deleted the node, so I could see there were errors for a couple of seconds, maybe a couple of seconds, because whatever requests that were handled by that particular um, that particular pod. Okay, so it looks like those requests got failed. But from the Kubernetes side, moment it moment it found that there is a pod got crashed, it will created a new pod in place of old one. Okay, so that happened immediately, and now it's able to handle so much of load. Okay, so yeah, thank you very much for watching this video. Yeah, in the next subsequent sessions, we'll try to discuss few other topics. Thank you very much.